To continue on with our Unit 2, which is all about equations. We are in Learning Target 2A right now, which is about solving equations. In this video, we'll talk about how can I take a word problem scenario, model an equation, and then solve that equation. So example 15 says an online DVD rental company offers gift certificates that allows you to purchase rental plans. You have a gift certificate for $30. The plan you select costs $5 per month. How many months can you purchase with the gift certificate? Set up and solve an equation. Make sure to define your variables or variable depending on the problem. So let's go through and read this again and start annotating on the paper about what information are we given. So we have this online DVD rental company and they give out gift certificates that allow you to purchase different rental plans. So what we have is we have a gift certificate for $30 and the plan that I'm selecting costs $5 per month. What we want to know is how many months can you purchase with the gift certificate. So as you can see, I kind of highlighted in two different colors here. So in the purple highlighter, I highlighted the kind of amounts of money that we have. So we have a gift certificate for $30 and we have a plan that costs $5 per month. And in yellow, I highlighted what we're solving for. So in purple is what we're given, and then in yellow is what we're solving for. Because the problem specifically says that we have to set up and solve an equation, although you might be able to calculate in your head how many months you have, we have to figure out, well, how can I take that and translate it into a mathematical equation and then solve that? The other thing it says is make sure to define your variables, so I'm actually going to start there. Our variables should be anything that we're looking for. In this example, they want to know how many months can we purchase. So I'm going to let M for months equal the number of months, because that's what we're solving for, is the number of months that we can use this gift certificate with. So we've now defined our variables. So I've set up and defined my variables, so I'll check that up. The next thing I have to do is set up an equation that I'm solving for. Well, our total gift certificate is for $30 and the plan we're selecting costs $5 per month. And then M is the number of months. So what that tells me is I need to make sure that my units work out. So if I go 5 times M, then what's happening with our units here, if I write it out on the side, is that's really $5 per month. And then I'm multiplying by M, which is the number of months. So the months would cancel and I would end up with a dollar amount. So 5M is going to equal our 30, since that is the $30 that was in our gift certificate. This would then be the equation. So we have now set up an equation and defined our variable that is in that equation. Now I want to go ahead and solve it. Well, to solve this guy, in our last video, we talked about how to isolate our variables. So this is a one-step equation because the only thing I have to do to get that M by itself would be to divide both sides of the equation by 5. And when I do that, we end up getting M equals 6 months. And since these are word problem scenarios, I'm going to go ahead and make sure that we are putting units each time so we make sure that they're working out from there. Okay, our second example has a little bit more going on with it. Why don't we go ahead and read it? So it says, Martha takes her niece and nephew to a concert. She buys t-shirts and stickers for them. The stickers cost $1 each. Martha's niece wants 1 shirt and 4 stickers, and her nephew wants 2 shirts and no stickers. If Martha spends $67, what is the cost of 1 shirt? Set up and solve an equation. Make sure to define your variables. So we're going to go ahead and highlight in purple the information that we were given. So the first thing we know is that stickers cost $1, so we know how much stickers are. Martha's niece wants 1 shirt and 4 stickers, and her nephew, I'm going to make this a little bit smaller, wants 2 shirts with no stickers. We also know that her total that she spent is $67. From here, in yellow, I want to highlight what we're trying to solve for. So it says, if Martha spends $67, what is the cost of 1 shirt? So what we're trying to find is how much does 1 shirt cost at this concert that she took her niece and her nephew to. So I'm going to go ahead and define that as X and define my variable right away and let X equal the cost of 1 shirt, since that's what we are trying to find. The other cost that we have involved here is the cost of a sticker, but that cost was given to us. So when we think about this equation that we're going to have to set up, there's two things going on. There's what does Martha's niece want, plus what does her nephew want, would equal the total amount of money that she spends. So I'm going to write that out more in a word format, and then we can figure out kind of how my variables and other pieces fit into this. So what her niece wants plus what her nephew wants, if I add those totals together, that should give me the total spent, total amount of money spent that she did. So let's refresh our memory. Her niece wanted 1 shirt and 4 stickers, plus her nephew wants 2 shirts and no stickers. So I could just write 0 stickers, but we're not going to have to worry about that since he didn't want any. And we know that she spent a total of $67. The other thing we know is that 4 stickers, since each sticker cost $1 each, then 4 stickers amounted to $4. So we already have that cost amount in here. So when we go to set up our equation using our variable x to represent the cost in each shirt, we know that her niece wanted 1 shirt, so that would be 1x, plus she wanted 4 stickers, but we already know that cost $4 total, plus her nephew wants 2 shirts, so that would be 2 times x, since he's getting double the amount. He doesn't want any stickers, so that's all that she's purchasing, and that will equal $67. From here, we can go ahead and solve this equation. We've now defined our variables, we've set up the equation, so those 2 things are taken care of, and our goal from here is to now solve it. Why don't you guys pause the video and solve it on your own first, and then we'll check it. Okay, let's go ahead and check this equation. So when I'm solving it, the first thing I notice is I can combine some like terms on the left-hand side first, so I can go ahead and combine 1x and 2x and get 3x plus 4 still equals our 67. Now I can move the 4 to the right-hand side by subtracting it, so we get 3x equals 63. To get that x by itself and solve for our variable, I can divide through by 3, and x will be equal to 21. And remember, x is representing the cost of 1 shirt, so that will be $21. So I put the $sign in there so that we have our units in play. Okay, here's our last example. So example 17 says it takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours, but it would take them 8 hours to learn the software first. How many web pages would the designer have to make in order to save time using the new software? Set up and solve an equation. Make sure to define your variables. So let's go ahead and use our highlighter and go ahead and highlight the information that we're given and what we're looking for. So we were given quite a lot. So it takes 1.5 hours right now for them to make one web page, and this is with the old software. Then there's this new software that would take less time, so each page would be 1.25 hours, but we first have to learn how to use that software, and that would take 8 hours. What we're after is how many web pages would the designer have to make in order to save time. So at what kind of breakpoint do we have where the old way would equal out to the new way? And at that point, if they're going to make that many, then it's probably worth it to learn the new software. Why don't you guys pause the video and try to write out what your scenario is and the equation that you have, making sure to first define your variable that you're looking for. Okay, let's check this guy together. So the first thing I need to do is define my variable. We're looking for how many web pages, so I'll use W, and let's let W equal the number of web pages. The next thing I want to think about is there's a lot going on here. So there's 2 ways that he can make these web pages. There's the old way, and he already has that current time for that. So I'm going to say the old time, or the current time. And then on the flip side, he has the new time. So the new time is less, but he has to learn how to use the software. And both the old time, this is per page, and so is the new time is per page. And we're trying to figure out, well, when would those be equal? So when does it outweigh it? Well, our old amount of time was 1.5 hours. That would be 1.5 times W, because it's per web page, equals our new time is 1.25 times W, since that's also per web page. But we have to have the amount of time it takes to learn this new software. And that's going to be adding 8 hours to it, because I only have to learn how to use the software once. So I don't have to do 8 times W, since this isn't 8 hours for every web page. That would be a lot of work. This is just 8 hours at the beginning as like a training, and then from there I use less time, so I use the 1.25 per web page. So we've defined our variables, and we have our single variable, and set up our equation, and now we need to go ahead and solve that equation for W. So why don't you guys pause the video and solve that guy, and then we will check your answer. Okay, let's go ahead and check our answer. So on either side of the equal sign, I can't combine any like terms. So right off the bat, I'm going to go ahead and move my 1.25 W and subtract it from both sides to keep the equation sign balanced. When I do that, I end up with 0.25 W equals 8. Personally, I don't like to use decimals. I think better in fraction, and so I can kind of rewrite this as 0.25, or I can rewrite it as 1/4 times W. From here, we've solved equations like this, and to get W by itself, I need to get rid of this 1/4, so I could multiply by 4/1, so that the 1/4 and the 4 cancel, and whatever I do to one side, I have to do to the other to keep the equation balanced. So the 4's cancel, and I get W equals, well, 8 times 4 gives me 32. So, making sure we have our units, that would be 32 web pages. So it would take this graphic designer 32 web pages for the old time to equal the new time. So if he's going to, or she's going to create any more than 32 web pages, then it would make sense for them to learn the new software first and go with that route as we solve. Now in each one of these scenarios, there is more than one way to set up the equation. So if you had tried one of these on your own first and you'd set up a different equation, but it was still equivalent to the equation we set up together, then that equation would work as well. Just making sure that you are defining your variables, setting up that equation first, and then solving from there.